Let's get started with part 2 of Lab 4, where you're going to locate an earthquake based on seismograms from 3 different locations in the United States. So in this example here, you're going to be using these seismograms here that show the arrival of the P wave here, and then this larger arrival here is the arrival of the S wave. We're not seeing the surface wave on these seismograms, so it's just the P wave and the S wave, P wave and S wave, P wave and S wave. And what you're going to do first is you're going to see what time the S wave arrived and what time the P wave arrived. And the way that you're going to do that is, this is reporting in minutes here. So here's 8 a.m. and 6 minutes, 8 a.m. and 7 minutes, 8 hours and 8 minutes, 8 hours and 9 minutes, 8 hours and 10 minutes. So let's do Sitka, Alaska as an example here. So we know that the P wave arrived in Sitka sometime between 8 minutes and 8 hours and 7 minutes and 8 hours and 8 minutes. And if we wanted to be more precise, we can grab this thing down here. It's divided up into 10 equal parts, and we can see that that very first P wave arrived just around 8 hours, 7 minutes and 0.4 minutes. So I'm going to fill that in here, 7.4. So for the P wave, it was 8 hours, and we're not going to really use the hours, but 7.4 minutes. And now let's see what time the S wave arrives. So I'm going to take the same thing, move it over here. It's kind of similar, but I think this one might be closer to 5. Oops. So I'm going to call that, and we can kind of nudge it over if we want to. So this is going to be 8 hours, 11.5 minutes. So I'm going to go back here for my S time. And then we're going to subtract the S minus P time, or we can just say this one's 11.5 minutes. And this one is 7.4 minutes. So the difference in time there is 7.4, 8.4, and 9.4, 10.4, 11.4. That's 4 minutes and 0.1 additional point. So that would be 4.1. Or you can just do 11.5 minus 7.4, and you'll get that 4.1. So now that we know, just like we see the lightning and we're waiting to hear the thunder, we know there's 4.1 minutes between when the P wave and the S wave arrived. So now we want to know what that distance is. And for this, we go back to the previous part of the lab. We go back to our travel time graph. You'll have all your points plotted on here, but what we're really going to use for this is the lines here. And I'm just going to draw a line, a vertical line that's 4.1 seconds long. So, 4.1 minutes long. So here we can see this is the travel time in minutes. Here's 0, here's 5, here's 10. I'm going to draw it from 0 up to 4.1. And then I have something like this line here. And then I'm going to take it and I'm going to see where it fits between the P wave and the S wave. It looks like maybe somewhere right around this area here is where it fits. So then I'm going to come down here, and I'm going to see that that's equal to about, let's move it up just a little more. So it's right between. So that's equal to somewhere around, depends on exactly how you want to scooch it, but somewhere around 2300 or 2350. So I'm just going to report in here 2300. And now I know how far away the earthquake was from Sitka, Alaska. It was 2,300 kilometers away. What you're going to do then is you're going to plot this onto this map here. And part of this is we have to know where Sitka, Alaska is. And we're given the coordinates of Sitka, Alaska. If you know where Alaska is, you may already know, but it's at a latitude of 57 north and 135 west. So here's the line of 50 north, 57 north, and then halfway between 130 and 135. So it asks you to label this as Sitka, Alaska, so you don't get confused here. Smaller. So this one here is Sitka, Alaska. And now we're going to add a circle around it. So because it's kind of hard to draw a circle of exactly the right radius here, I kind of provided some circles here, and we said around 2300, or what do we have on our table here, 2350, 2300. So look for the closest circle here to whatever radius you have. So 2800 would be too big, 1900, this one's just right. I'm just gonna copy it and then paste it onto my map. And of course, this is the distance the earthquake was away from Sitka, Alaska. And so I'm going to center it right on Sitka like a bullseye. So the earthquake occurred somewhere on the outer edge of this circle here, because all these points on the outer edge of this circle are 2,350 kilometers away from Sitka. You're going to do the same thing for the other 2 points. You're going to fill in the rest of this table. You're going to put the other 2 circles based on the distance away from the earthquake on your map. And if you're successful, all 3 of those circles should intersect at one point on this map. 3 circles are only going to intersect at one point. And that's going to be where the earthquake, the epicenter of where the earthquake occurred. And you're just going to work through the rest of that. You'll label where the earthquake epicenter is. You'll let me know if you think it makes sense that an earthquake would occur in that place. Some places like Kansas, it's less likely an earthquake would occur. Other places like offshore Oregon, it's more likely an earthquake would occur. So think about whether your place makes sense from a plate tectonics point of view, and then go ahead and answer those questions.